Hello and welcome to my channel. My name is Uğurcan and I am recent computer engineering graduate from Fırat University in Turkey, what you might know as the computer science department. I won't keep you long, but I recreated the game Harvest.py, which I made specifically for my mother, who has a special fondness for the original version of the game. I decided to share this remake here, in case there are others who also miss the Flash player version of the Harvest owners and might enjoy playing it. Although the code is my own work, all rights to the game's name, music and visuals, essentially all copyright materials, belong to Azerion. Should Azerion request the removal of the download link or this video, I will gladly comply with their request. Now let's get into the game. Now let me provide some details about the game. I haven't worked on the project enough to implement features as seen in the original game, matching items like shovels, pots and water. Currently all objects match with a 1-time score, except for carrots which provide a 2% score. The first to reach 100 points wins. As you can see, the game features 3 difficulty levels. If you choose hard mode, the CPU will never miss a move and will always make the most optimal play, making it quite challenging to win. I choose normal for video. I'm not so good at this game. I miss. Yep, I won. That's enough. Okay, now let's dive into the code for those who are interested. Since I created this project as a fun, impromptu endeavor for my mom, is not a project that was completed in one sitting. Additionally, because the project contains over 600 lines of code, I will be giving an overview of the code in this video. rather than coding the entire game from start to finish. However, stay tuned for the live coding videos in the coming days. Okay. Resource path takes a parameter called relative path and returns the corrected path relative to the application's directory. This ensures the correct path is obtained if the application is running within a package. This section of the code defines various constants related of the game's display and layout. It sets the overall screen dimensions, the offsets used for positioning elements globally and within specific sections, and the size and number of blocks in the grid. Additionally, it calculates the exact positions for the background, score display, and game grid on the screen using these offsets, ensuring that all visual elements are properly aligned. Let's continue. These are our objects: shovel, water, pot, carrot, stone, etc. Represents the game board typically as a two-dimensional list matrix. This function assigns a random block type, color or character to each cell on the board. Blocks can be arranged in a specific pattern or randomly distributed. Load sounds, play music, play effect, update screen. Update screen. As you can see, screen grid, player score, CPU score, player turn. Draws the game board grid on the screen, displays player and CPU scores, and indicates whose turn it is. This function updates all visual elements on the screen to maintain visual consistency. Okay. Fill empty space. If a specific cell is empty, this function redirects the block above it or places a random block. It ensures that gaps on the game board are properly filled. Check matches. Identifies matches on the game board where 3 or more blocks of the same type are aligned horizontally or vertically. Updates the score and removes matching blocks from the board, filling in gaps. Move animation handles the animation of the blocks detected and selected and released by the player on the screen. This animation visually represents the movement of blocks and enhances the game's dynamics. Player move processes the player's moves and based on the blocks selected and released with mouse, updates the board, scores and trigger animations as needed, determines the outcome of the player's move. Find random move. Determines which two blocks the CPU will move between, selects two blocks randomly and performs a move between them. CPU move. Choose the CPU's move depending on the difficulty level, selects the best move or makes a random move. This function defines the CPU's strategy and continues the game. Difficulty section. Displays buttons on the screen representing different difficulty levels. The player selects one of these buttons to set the game's difficulty level. Buttons, positions, colors, visuals, etc. Okay. Find best CPU move. The find best CPU move function aims to determine the most advantageous move for the CPU by evaluating all possible moves on the game board. It starts by generating a list of potential moves, which involves examining each possible pair of blocks that could be swept. For each possible move, it assesses for resulting game state to identify and any matches that would occur and calculates the associated scores. The function then uses these scores to compare the effectiveness of each move. The move with the highest score, indicating the most beneficial outcome in terms of clearing blocks or maximizing points, is selected as the CPU's best move. This approach ensures that the CPU makes a strategically sound decision, enhancing its competitiveness in the game. Calculate move. Calculates the score for a particular move based on the matches it creates on the board, assesses the impact of the move, and determines how advantageous it is. Find matches recursive. Recursively searches for the best matches that can be created from a given starting position, evaluates all possible outcomes, and provides the optimal result. Okay, game loop. Game loop runs the main game loop, manages player and CPU moves, updates the screen and the checks for the game ending conditions. The game continuously runs within this loop. Check winner. Compare scores to determine the winner. If a player's score reaches a certain threshold, identifies the winner and displays the appropriate message on the screen. Display winner. Display winner. Displays the winner name or a message on the screen when the game ends, allows the player to see the results and the outcome of the game. Let's start game. Let's start game. Let's test game. Main. Our main function starts the game loop, handles the difficulty selection, and initializes the game, manages the main logic and flow of the game, including setup and game execution. Okay, that's all. I can't win against hard CPU. No, okay, I can't win. Okay, thank you for watching. See you later.